Hello guys, welcome back. In this video, let us understood how to identify which model best fit for our problem, which ML model is best fit for our problem. So that we gonna understood now. So to understood this, I'm taking a real time scenario like I'm taking the house prices. That is, we will take two parameters. We'll pass like the input feature here is the house size. We will provide the square feet, and with that square feet, what is the cost of that house at that particular location. Let's say I'm buying a house at there, like USA, I'm buying a house. So in US dollars, how the price will be. So that I'm considering for, that is I'm taking some sample of a data set where it contains the house sizes as well as house prices. Now I want a ML model where that can able to predict the price for specific size. If I provide another size that is not present in my data set, for that size also my ML model need to identify approximately nearest or approximately the same price as similar to the actual price. So like that, my model need to predict the house price based on that given data that I have provided to my model. Based on that, it need to predict the house price. For our use case, now I'm just taking this data. That is, I've taken this example data set. So these steps are nothing but the next steps. I'm just taking this data. Like so, what are the sizes of my houses and what are the prices currently for those size related houses? So what are the prices of the houses and what is the size? So that data set I'm taking. Then what is my first task? Based on this input data set I have, I need to visualize the relation between my input as well as the expected output. I need to actually predict the relation, exact relation, what might be the exact relation between the input and output. So that if I have particular input, then for that input I can able to predict my output based on that relation. What is the relation between them? So that we need to understood at first. So in order to understood, I first want to visualize this data set. This data set I want to visualize and understood in the form of a graph. I want to visualize it and I want to understood it. So first what we need to do is we need to visualize that data set to understood that data set. Then after visualizing that data set and identifying the relation between input and output, then we actually prefer the model, that algorithm or the relation between the input and output. We can say it as an algorithm. We have multiple already available models are there, ML models are there. We can actually prefer one of them which best fit for our requirement, or we can even derive our own model or own algorithm based on identifying or based on this visualized data set. So now let's say we visualize the data set, and from that what is the second step? We need to find a model. Let's say we find the model as well. Then so what is the third step? After finding the model, like we need to find a model. We need to find a model, and then after finding that model, we need to again plot the data with our model so that we can able to observe or identify how the actual model will be. So that thing we will be identified. So we'll again visualize the same thing. But now we'll visualize the data as well as the model, whatever the ML model that we created, that we can visualize now at the end. So these three tasks that we do now. So first we have this data. Let's visualize the data in a graph format, and let's identify what is the relation between the input and the output. So to visualize it, I want to create a data frame. So how can I able to create a data frame? First we need to import a library that is pandas. I'm importing it as a PD, and by using that PD, I'm defining a data frame. PD dot data frame. Okay, so this command I'm using, and I'm passing this data so that this data is converted into data frame, and I'm just storing that into this variable. Then after I want to just plot this data. I want to just plot this data frame data. How can I able to plot, or how can I able to see that in the form of a graph? So to see that, we need one more library, that is Matplotlib. We need to import Matplotlib dot pyplot. I'm importing it as a PLD, that is plot. In simply I remember PLD like this. And let's visualize the data, whatever the data frame that we have, let's visualize it. So plot dot scatter is the command that we need to use here. Since we are representing the data points, we are using this. Whereas if you are expecting to represent some continuous representation, then we use the plot. Now I'm defining what are my x variables. So in my data frame, whatever the size or whatever the data present in this is size, my house size, I'm taking it as x variable. And what about my y variable? That y is nothing but my output. What is my output? My price. So this I actually need to predict. This is my actual input. And I want to provide some color to these points. Like I want to provide some blue color, okay, so that my points will be blue colored. And we can even provide some label to this data, like by using this label command. So this is related to data points. I'm plotting only data points, so that's why I'm providing a data point as a label. Okay, now we provided x and y values. Then we just write the command that is plot dot show, and let's run this. Okay, now you can see we got the graph, right? Yes. So these are the data points, how it look like. So let's make it some more clear, so that let's provide x-axis, what is the x-axis, what is the y-axis, what is the title of it, so that we can able to visualize it a bit more better way. So let's write those as well. Let's write the plot related title, so that it will be very clear to us. House price, house price versus house size versus house price, right? Yes. House size, so it's the x-axis value, and price is the y-axis value that we provided. So that's why we provided the title like this. I want to provide the label for x-axis as well. I'm providing the label like this is nothing but the house size, so that is in square feet, okay. And y label I want to provide like the price that is in US dollars, currently we consider like that. Okay, now I'm just printing it again like a plot dot. I'm just rerunning this, so you can see, yes, the label we got, the title we got, the labels also we got. Now I want to see the legend, like so this is the label, right? That also I want to see. If you want to see that, then just try to plot dot legend, so that you can able to see the labels as well. Yeah, you can see this is the data points. Okay, now we plotted our data points, whatever the data points that we have, that we plotted. Now let's visualize this data, how the relationship between our input, that is a house size, as well as our prices, house prices will be. Can we say it is increasing? Yes, we can say that it is increasing. It is increasing linearly like this, right? Yes, it is increasing linearly. And can I say, if I have a model like this straight line, if I have a model like a straight line, okay, just I'm expecting to draw a straight line. Okay, so like this, if I have a model like this, a straight line, can I say that model can able to predict the future values as well as the past values? Like if I provide the size which is less than this also, can I say this model can able to predict the approximate value? Yes. If I provide the value which is greater than this, so for that also our model, or so this line can able to predict it. Yes. So what we understood from this, like, so first we have seen how our data will be. So what is the relation between our input as well as our output? So how the data relation will be? So if I plot a line like this straight line, then this line is best aligning the relation between these two, like inputs as well as the outputs. For the particular inputs, these particular outputs are highly aligned with this line, right? Yes, this line is best fit for those inputs as well as the outputs with or the current data that I have for that. So like this, can I say this line represents, or this line represents the relation between our input and output? Yes, this line actually represents the relation between input and output. So can I say, if I define this line, can I able to predict all the house prices? Yes, we can able to predict approximately almost same prices as the original prices. Okay, now let's understood how to get this, or how do we define this line. So if you take a line, then that a line equation will be like this: y is equals to mx plus c. That means it's a normal straight line or linear line equation it is. So here now we consider bias as a, or some random noise we call it as. So this is how the graph will be. Like m represents the slope of this current line, and this b represents the base value. Let's say if the slope is 0, if b is also 0, then this is the straight line it will be. If b is 1, where slope is 0, then this is the line it will be. If b is b is 1, then here the line it will be. So from 1 it will be like straight. Let's say, since for our all points, what is the common, or what is the minimum distance line that will be considered? So in middle, if let's say there is a no slope we are considering, then this is the line, this is the straight line will be the answer related to b, only b. If we set the slope, currently for this the slope is 0. If we change the slope based on the points, so currently from here to this is the actual point, this is the actual point, This is the value that we are getting for this house price. Based on a slope, if we adjust this, like this point may comes to above, and for this also, if we adjust like this, if we move the line, and here also it supports to move downside, right? Yes. So if we just change the slope, and if we move the line, then so this straight line, whatever the straight line like this, it will move like this, like it will just adjust like this. Then based on further adjustments, our exact line, that is this, whatever the exact line that we require, that we get from this point. So based on adjusting the slope as well as the b value, we'll get the exact value of our line. So this is the linear graph that we can able to get from these, adjusting these two values like m and b. So like this, in real time, we need to identify what is the relationship between the input and output. So during that time, you may plot the graph as well between input and outputs. If possible, you can able to plot the graph between input and your outputs. Then based on that plot, you can able to classify the or identify the exact relation, what the relation may be, so that you can able to identify. And by using that relation, you can able to create a model, and you can able to actually train your model, and you can able to use it in future for your purpose, like for predicting new house prices, new houses related prices. Based on the size, you can able to predict a new house related prices as well. Now, so now I don't want to manually set up this b value or this m value. I want to use the advantage of already available ML models. Is there any available ML model where that provides me this linear graph, and that can able to directly adjust these slope values as well as these b values? Yes. If we provide some sample data like this input features as well as this output y value, then we have a model that is a linear regression model. That model, linear regression, is nothing but this is the same equation that model has. That model will directly adjust their weights. So the slope, we call it as weights here. This weights that will adjust, and this biasing also, that linear regression model will adjust. Now I'm just clearing the graph. Okay, so for this data, now I want to predict the model by using some already available models. So since a linear regression model is the best fit for it, like since it's a linear related graph, the line we call it as a linear, straight line we call it as a linear graph. Since it's related to linear based type model, I am expecting a linear regression model. So where that a linear regression model is present, that is present in sklearn library. In this, not only this linear model is present, it also have multiple other models, ML models are there. You can use it for importing the already available models. Okay, now I imported this linear regression model from sklearn library from this linear model. Now I want to define that model, or I want to load that model, I want to fit that model. So that's why I'm creating this model variable with this linear regression. Then I want to train my model with the data set. So that's why I'm writing model.fit. Fit is the function that we use to train our model, and x is nothing but the input, y is nothing but the output I want to use. So before using them as input and output, we need to define those parameters. What is the x? Nothing but your features, input features. So what are your input features in my data frame? My input features are nothing but this size. So that I'm providing here as my input features, as well as my output features. What is the output feature? My output feature is nothing but this price. I'm just copying and pasting that here. Okay, I'm just taken the input features as well as the output targets, and I'm training my model so that I can able to get the model. Now I want to pass the same input values and predict the output as well. If we require, then we can able to do that as well. So I'm just want to predict the output response. How can we able to predict the response? So just model.predict is the command that you can able to use, and you need to pass the input, the same input I'm passing. So this is the actual output. This y is nothing but the actual output, and this y predicted is nothing but the predicted output. So at last I want to plot this, so that's why I'm just copying this and pasting that here, so that all my points will be visible right now. Now I want to plot one more thing, that is I want to plot my line as well, or you can say my linear line I want to plot. So since I want to plot a continuous line, continuous points, I need to write this plot command, and the x values are nothing but this sizes only, whereas the output is nothing but my predicted y value. So that's I'm providing for my line, and this is related to line, right? Yes. So this is related to my linear regression model. This is related to my linear regression model. And what is the color I want to specify is, let's consider red. Okay, now I'm just rerunning it so that we can able to see the next time graph contain. This is the plotting of original data points. We visualized it. Then after we considered the linear regression as a best fit solution for my requirement, and then we are plotting it. So I think we got some mistake or we encountered some mistake somewhere. Let's identify it. So where we got in this so model.fit command, we are getting some mistake. So what might be the mistake? So here I think we need to provide it as a list of list, and let's try it. Okay, again by plot. Okay, here also we need to write a plot spelling correctly. I'm rerunning this code. Okay, now I hope this is working well. Yes, this is working. Now you can see, so this is our linear line that is created by using this linear regression model based on the training data set that we provided. This is the best line that finds the relationship between our inputs as well as the outputs as well. Now, currently for this problem related to house sizes, house prices prediction based on the house sizes. So this is suitable for me. But in real time, you might have other use case or other need or other business problem is there. Based on that, you need to plot your data and visualize your data, how it will be and how you are expecting your model to be, how you are expecting your model output to be. Based on that, you need to identify the best suitable ML model for your requirement. If there is a no best model for your requirement, then you need to define or you need to create your own model. You have multiple algebraic equations are there. So you just observe the pattern in your data points and you just need to try with multiple mathematical relations, like you have exponential functions, you have logistic models, you have sigmoid functions, you have sine related and cosine related graphs you have, and we also have these type of linear models and non-linear models are also there. So based on your requirement and your use case and your business problem and your data output requirement, you need to predict which is the best fit for you. If there is no such available model is there, then you need to define your own model based on the relationship between inputs and outputs. In this way, in real time, we can able to identify the exact model or ML model that best fits for your requirement. If we recap how we selected a specific ML model for our requirement, then you can observe that we visualize our data set. So whatever the data that we have just visualized the data set, and we plotted the input versus output graph, and we observe the best suitable relation. Then we identified the best suitable ML algorithm that is already available. If we do not have a best one available, then we need to define based on our data relationship. Then after, so that relationship also we defined like so y is equals to mx plus c. So like that we defined the relation. So such type of model is also there. That is this linear regression model. So that's why we're using this model. And then we have also seen the things like we trained the model, and we have also seen the graph, like after plotting that, after using that model, after training that model, how the response will be. So that also we plotted in the result. So in this way, in real time, you need to predict a ML model based on the problem or use case or business requirement, and you need to use that model for solving your requirement. I hope you understood this video and you got some good knowledge from this video, and I feel this video is useful. If you feel this video is useful, then please like, share, subscribe and hit the bell icon to get the latest update. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye guys.